All right, let's start off on number 2 here. So we got some quadratics, so we want to get one side to 0. So I'm going to move everything to the left here because I like my squared to be positive. So I'm going to add 5 and subtract k squared from each side. So that'll 0 out my right side, and then my left side will be 10k squared minus 45k plus 20 if I just combine like terms. And next up, I noticed that everything can divide by 5, so I'm going to go ahead and do that. You can do this anytime we have an equation here. So let me get 2k squared minus 9k plus 4. Now I'm going to try to factor this, thinking of two numbers that multiply. It's a times c, which is 8, and add to b, which is negative 9. And so that's going to be negative 8 and negative 1. So now I can split that up. I do have to use my grouping here. So negative 8k and negative 1k according to this. And I'm just going to bring this down. So I got 2k squared and I got a plus 4. So now I'm going to group here. The first group I can take out a 2k, which leaves me with k minus 4. The second group I can take out a negative 1, which leaves me with k minus 4. I had to take out that negative, so now the inside of my parentheses are the same. And so now I can make it one parentheses for the stuff outside and one parentheses for the stuff inside. So now I'm going to split this up. So 2k minus 1 equals 0. K minus 4 equals 0. I add 1. 2k equals 1. And k equals 1/2. And then over here I'm going to add 4. And so k equals 4. All right, once again here, number 4, I'm going to get one side to 0. So we got 5x squared minus 2x minus 1 equals 0. Now we'll try to factor with two numbers multiplying to negative 5 and adding to negative 2. But no numbers work. And so that means I need to switch over to quadratic formula. So that's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So b in this case is negative 2, so I have to say negative 2 plus or minus the square root of negative 2 squared minus 4 times 5 times negative 1, and then all over 2 times 5. So negative 2 is just positive 2. So I'm just going to simplify this, and then this will be 4, and this will be negative 20 times negative 1, so that's plus 20 all over 10. So then I have 2 plus or minus the square root of 24 all over 10. Now I need to break down this 24, so I can break down into 6 and 4, 2 and 2, 2 and 3. So I have twin 2's here, so they're going to go outside. So I got 2 plus or minus 2 radical. I have a loner 2 and a loner 3, so they're going to stay in the house as 6. And lastly, I'll just reduce this with the heart. So 1 plus or minus radical 6 all over 5. All right, next up here we got the discriminant. So the discriminant is b squared minus 4ac. It's really the inside of the radical on the quadratic formula. So if that is positive, that means it's 2 real solutions. If that is 0, that means it's 1 real solution. And if that is negative, it means it's 2 imaginary solutions or no real solutions since they're imaginary. So I see here a is 4, b is negative 1, and c is 3. So I'm just going to do negative 1 squared minus 4 times 3. So that's 1, and then this is minus 16 times 3. That'd be 48. So minus 48, that comes out to negative 47, which means we have 2 imaginary solutions since that came out negative. All right, next up here, we're going to solve by taking square roots. I know we can do this because we don't have a b value, so I can just isolate the squared. So in this case, I'm going to add the 7 over. So I get x squared equals 60, and then we will square root both sides. Now I'm going to break down the square root of 60, so that'll be 6 and 10, which is 2 and 3 and 2 and 5. So I can pair up the 2's, and they're going to be leaving. So that'll be 2, and then these guys are loners, so they're going to stay in the house and multiply back together as 15. But since I created that square root, I'm going to have to put a plus or minus in front. All right, next up, I'm going to have to solve this systems of equations. So I'm going to take this and plug it in for y over there. So it's x plus 3 equals x squared minus 3x minus 18. So now I'm going to get one side to 0, so I'm going to subtract x and subtract 3 from each side. So I get 0 equals x squared minus 4x, and then minus 21. And now I'm going to factor that. So we're going to think of two numbers that multiply to negative 21 and add to negative 4. So that'll be negative 7, positive 3. I can do my shortcut here since we don't have a number in front of x squared. I can just say x minus 7 and x plus 3. However, now I need to set those equal to 0 and solve. So x equals 7 if I add that 7 over. And if x plus 3 equals 0, I would subtract the 3 and say x equals negative 3. Now on these problems where we have two equations, we have to plug those back in to find y. So I'm going to go ahead and plug those in. This equation looks easier up here. So I'm going to say y equals 7 plus 3, so that's 10. So that means that point is 7 comma 10, because when I plugged in a 7, I got out a 10. And then the next one, y equals negative 3 plus 3, and that comes out to 0. So I plug in a negative 3 and I get out a 0. All right, next up we need to find the value of c that completes the square. So anytime we're trying to complete the square, we always want to do b over 2 squared. So in this case, that'll be negative 12 over 2 and then square it. So negative 6 squared is 36. All right, next up here, we want to solve these by factoring out a GCF. So we want to get one side to 0 first. Now number 14, I see I already have one side to 0. And so I see that these both have 4b that I can take out front, and that'll leave me with b minus 5 on the inside. Now since I have a variable here, I do need to set this equal to 0, and I have set b minus 5 equal to 0 as well. So I'm going to divide each side by 4, and I get b equals 0. So I'm going to add 5, and I get b equals 5. All right, next up here, we're going to figure out what type of function this is and write an equation for it. So we're going to look at the y values here and see if they have a pattern. So I'm going to first look at subtraction here. So what is that? What would I have to subtract to get from 64 to 16? That would be negative 48. And then this one would be negative 12. And this one would be negative 3. And this one would be negative 3 over 4. So obviously that's not the same, so I can say that this is not linear. And so I'll check quadratic next. So we just check the next level of this. And this would actually be plus 36, and then this one would be plus 9. And then I don't know what that last, I could figure that out, but I don't really need to because I know it's not quadratic since those first two are not the same. So that really means then that it's probably exponential. And so when it's exponential, it's going to be in the form y equals a times b to the power of x. And I know a is the y-intercept, so it would be 0, comma a. So in this case, that's 0, comma 16. So that would mean a equals 16. And then for b is any y value divided by the one right in front of it. So I could do 4 over 16, or I could do 1 over 4. But either way, it comes out to 1 over 4. So that's my base, 1 over 4 to the power of x. All right, next up, same idea here. I'm going to check this out. This looks like plus 10, and then this one looks like plus 14, and then this one looks like plus 18. So it's not linear. However, I see here we do have a plus 4 pattern on the next level, so that means it is quadratic. Quadratics are always in the form on these questions of y equals ax squared. So I'm going to go ahead and I can grab any point. I'll just use the smallest one for my x comma y. I'm going to plug an 8 right there. I don't know what a is, but I know x is 2. So I get 4 times a equals 8. And then divide this by 4. And I get a equals 2. So then I can write my equation as y equals 2x squared.